Hello everyone, this is Ari from Pantech. So in previous session we have seen into the concept of we have getting into the concept of interrupts. So today we are going to do some we are going to implement those interrupts. So we will develop the code for external interrupt. So we will connect. We are going to give an external interrupt. So as per the interrupt, it is going to interrupt going to be handled. Okay. So we are going to use this interrupt handlers. Okay. So what are the steps we have to do? So before that, what are the steps we have to do? So we will see. So before getting into the next topic, now you can convert this masterclass into an internship, guys. So it is in a 1 month internship on embedded systems. So we are already learning the STM32, which is based on ARM Cortex M4 in a register level, right? So we are learning like in a register level. So it will be very much useful for you. So you can you have to when you have to improve yourself, you have to practice on these things. So while practicing, you need some internship like reference, like what are the ins, what are the bugs, all things you have to need some reference, right? So for that purpose, this internship is provided. And in what is the benefit of this internship is lots of topics you can refer to this internship, and lots of things going to be added in this internship, like CAN, LINs, lots of communications and tax core concepts all coming on the pipeline of courses. So don't miss this opportunity. Our fees is 1,200. So our discount price is 599. Okay. So you can use this ESMC1 coupon code, and by using this, you have to pay only 691 only. So by paying this fees, you can register for the internship and you can get more benefits. Okay. So now we will get into what are the benefits you will get. So as I said, so we are practicing lots of codes, right? So we are practicing lots of codes in the live session, and you are developing lots of core concepts. So you have to practice yourself for making to upskill yourself, right? So when you are practicing, you will come with some errors, or you will have some doubts related to those things, or you will after executing the code, you will not get output like these things. So for that purpose, you can refer to these 30 days videos. So what is the best benefit is the 30 days of masterclass live sessions will be available as a recordings in this internship. So and lots of topics also going to be added to those videos. So it will be accessible for those recordings will be accessible for 90 days. So you can use those videos as a reference for hands-on practice and developing a while developing a code. And even the concept is you are not clear with the concept means you can again rewatch it. So the concept will be get clear. Okay. So and what is the next benefit? So next benefit is we are going to do lots of hands-on practice on embedded projects, and you are going to implement what is the project I have teached you, and you are going to implement those in real time by yourself. So while developing the project, you will get lots of errors and lots of bugs. So you can in this internship we will provide a lots of practice on embedded projects, and you can ask the questions to clear the doubts to myself as a me. Okay. And what is the next benefit? So next benefit is you will get a 30 days of download presentations. So I'm giving a presentation right for 30 days. So you will get this. Plus additionally, what you will get is what are the things we are using. We are using data manual, reference manual, programming manual, user manual, lots of things. So those are all the things what are we are using to develop the code, and all the things we use to learn the core concepts and communication protocols. All those files also will be included in these 30 days of downloadable presentations. So you will get the presentations as well as what are the things we are using for developing the code and the projects. And also in addition, you are going to get a codes that I am developing. So I have developing a code in live sessions, right? So those codes are going to be .c files. It will be shared you as in a format of .c file. So you can refer to those codes also. So that will be exclusively available for these internship students. So you can you can get those codes also. So you can use those codes for reference also. Okay. And what is the next benefits is we will have a one-to-one live sessions. So what is this is you can interact with me for 1 hour every Saturday class. So you can ask the doubts, you can clear the topics doubts related to the topic which I have taken from the day 0 to till the date, or even you can ask the doubts related to the embedded systems out of the topics which I have. Now I am taking STM32, right? If you have a doubts related to the other microcontrollers, or you are doing lots of or you are involved in other embedded projects, you have a doubt related to those projects, or you have doubt related to this other microcontroller, means you can also use those mastermind class to sessions to ask the questions related to the out of the session also. So you can ask the doubts related to the embedded systems out of this STM32 also. So you can use this mental life as these opportunities. So this is about how you are using your this opportunity, how you will make use of it. So you can also you can ask me to, you can also prefer me to do and take some new topics some topics you some core concepts you like to be learned, right? You would be want to learn those concepts. So you can say it in my Saturday class to me directly, so I can prepare on those topics and I will be giving a presentation in this internship. So it will be very much exclusive for the internship students only. Okay. So those even out of the topic, not based on STM, if you can ask, if you want other topic more than out of this team is, you can also ask me that. So you can prefer me that. So I will take this. I will get into the topic and implement those things, and I will be giving you a recorder session for you, and also I will give a code on developing those things and it for while implementing in a real time. So these are the benefits you can get by this internship. So this is about how you are using this opportunity. Okay. So next is after registering, you will get an internship confirmation letter. So after registering, you will get a confirmation letter, and two, you are going to get a 2 e-certificates. What is this benefit? So you can use this certificates in the resumes. So what is the benefits? Is we are learning STM32 based on Oncodex M4, which is a industrial based controller in a register level, right? We are not using a advanced library. All libraries are some things which will be very much easy, like Arduino programming. So we are getting into a register level. So it is in a from zero to ground. We are starting from ground to advanced, right? So this is a basic step. So we have to know about registers to develop the all GPU like drivers. So we are learning STM32 in register level. So this certificate will be very much useful for you. So what are the two certificates we are going to give? We are going to give two certificates. One is for participation and another one is for course completion on this STM32 register level. Okay. So it will be very much useful to you. So the internship fees is 1,200. So don't be afraid. So you don't have to pay this full amount. You can use this ESMC one coupon code so that you can get this 509 discount. And the discount fees is 691 only. Okay. So you can get the internship at 691 only. So this is the registration link, guys. This registration link will be available in the chat box. You can see this, or you can see this description box. In the description box, there's a registration link will be available. So join as an internship user and use this internship as a upskilling opportunity for yourself. Okay. So we will get into the concept. So what are the things we are going to do? So first we will create a GPIO config function which will enable GPIO. So then it is based on which is port we are using, and we have to set the mode or register, which is what is the mode we are using, alternate function or input function or GPIO output purpose. Okay. So next is pull DR register. We have to say the pin is in a pull up or pull down. Okay. So what is next thing we are going to do is we are going to create a inter config function. So in this we are going to enable this system clock control, and we are going to select the external line, which is external interrupt line, and we are going to disable the interrupt mask, and we have to select the whether we are going to read the rising edge or falling edge, and we are going to set the priority, and finally we are going to enable these interrupts. Okay. So now we will develop the code. Before that, we have to then say the interrupt handler. So what are the things we are going to do in say the interrupt handler? So what does interrupt handler means? So when the interrupt is generated, it is going to the NVIC is going to force the microcontroller to all the program and get into the ISR routine, which is a interrupt service routine. Okay. So check the interrupt. So what we are going to do is this interrupt is same interrupt is generated from the same external line. So we will check this and we will clear the, when it checked, we will confirm this. This is the interrupt from the external line. So then we will clear the pending request in the pending register and we will do some operations. Okay. So this is the thing we are going to do. Now we will get into the code and we will develop on it. So the Pantech e-learning is offering a 100% placement for your students who was trying to get into the embedded engineer domain or Python domain, Java's data science domain, artificial engineers, and electric vehicle engineering. So these are the domains we are focusing on. The Pantech e-learning is focusing on these domains and providing a 100% placement for these domain-based industries and companies. So guys, you can enroll for this. This link and link will be provided in the description box and as well as chat box. Or you can also use this QR to scan and enroll. So you can join our team. Want to make a career as an whatever domain you needed. So what is the thing we are going to do here is we are analyzing the industries around us. So we are seeing what are the technologies they are asking for them, asking from the students. What is the technology they have the industry required? So what is the technology that the industry needed? So we are analyzing those things, and as per the industrial requirements, we are training the students, and we are teaching them how to attend the interview and all the things, and we are giving them a 100% placement on based on the domain core industry. So if you take embedded, you will take a scenario of embedded engineer. So you will get a placed in the embedded domain. So we are the training is going to be based on the what is the as per the industry's requirements. So what are the technologies they are asking from the students? So those technologies going to be teacher you going to be get teacher going to train you for the this course for up to 3 to 6 months, and we are going to give you a offer you are we are going to make you placed in this your dream companies. Okay, so guys, don't miss this opportunity. So you can enroll this. So enroll as soon as to get this. Lots of offers are going on. So you can enroll who's getting first will get the best offer. So register this and get a best offer and get placed in your dream company. Okay. Okay. So what is the first thing we have to do? We have to add the startup file. Okay. So we will add this startup file. So next we will get into the program. Okay. So what is the first thing we are going to create? We are going to create a void of GPIO which will configure the GPIO. Okay. So in this GPIO, what is the port we will use the external interrupt of 3. Okay. So we will in our scenario we are going to use this external interrupt 3. So what is the port we are going to use? Wait, I will open this data sheets. So go to the RCC. This AHB1 plus. Okay. So what is the port we can use? We will take the port D. Okay. We will take this port D. So we have to send logic 1 to this. Port D is in third bit. So this will enable my clock. Okay. First I will do this. First I will RCC out. AHB. On left shift of 3. So this will enable my clock for GPIO T. Okay. Is it correct? Okay. So next thing we have to do is we have to set the motor register. So go to the GPIO registers. Okay. So in this we are configuring the pin as we are going to configure external interrupt of 3. So the pin will be 3. Okay. So we will make this as an input. So it is in the reset state. So we will make this motor register is equal to 0. Okay. GPIO is equal to we will make it as 0. Okay. So this will set 0 in the all these bits and make the all the pins as an input. So it is not an issue. So we will configure this first pin. Okay. Sorry, pin of 3, external interrupt of 3. So this pin on. So it will be logic 0 will be settled in this 7 and 6. Okay. So as an input. So what is the next thing we have to do? We have to get to the full year register. Okay. Go to the, so here is a full year register. In this, you have to configure this pin 3, right? So 6th and 7th bit. So in this, you are going to select this mode as a pull up mode. Okay. So then we have to send logic 1 to the 6th bit. So it will enable my logic 1 to the 6th bit. So this will enable the ED of 3. Okay. So it is in the port D. So pin of 3. 0, 1, so on less than 6. Okay. So what is the next thing we have to do is, now we have finished the GPU configuration function. Okay. So what is the next thing we are going to create? We are going to create a void of interrupt config. Okay. So we will make this void. So in this first, we have to enable this system clock control. Okay. So go to the RCC registers. In this we have RCC. In this registers, go to the edge ABB to ENR. So we will have this system clock control configuration in this 14th bit in this ABB 2 bus. Okay. So we have to send logic 1 to this system configuration controller clock enable. Okay. So we will send this CC of. So what is the bit we have to send? Logic 1. So we have to send to the 14th bit, right? So logic 1. So this will enable my system clock control. Okay. Cross check it. So it is in the 14th bit of okay. So now we have settled. What is the next thing we have to do? So now we are getting into a new set of registers. Okay. So go to the system configuration control registers. So in this we have an except system configuration control external interrupt configuration. Okay. So we have three control registers for external interrupt configuration. So control register 1 has the external interrupt from pin from 10 to 30. Okay. So 10, 11, 12 and 30. Then when you come with 2 means we will have a pin of 14 to 70. Okay. So next we will come to the 3. We have a 3 in control 3 register. We will have the pin from 8 to 11. Likewise in 4 we will have the pin number 2 to 5 and so we have 5. So what is the interrupt we are going to configure is external interrupt of 3, right? So we are going to configure the external interrupt of 3. So wait. So you can see we have a in 4th register only, in control register 4 only, we have a pins of 15 to 12. It is going from 15 to upwards. When it comes with control register 3, it is from 11 to 8. When it comes with control register 2, it is 7 to 4. Then when it comes with 1, it is 3 to 0. So what is the external interrupt we are using? We are using is external interrupt of 3, right? So what is the port we are using? We are using the port as port D. So what is the sum of the values? 1 plus 2, it is 3. So I have to left shift the logic 3 to this 12th bit. Okay. To select this external interrupt of 3, like So I will send this. So in CFG in external interrupt of, in which control register we have it? We have it in control register of 1. So we have to mention it here as 1. Okay. So 1. So I'm going to left shift this 3 to the which bit? 12th bit. So this will set my logic 1 in this 13 and 12. So then it will select my port D pin, which is 3. Okay. So now we have selected the external interrupt line. Okay. 3. So what is the next thing we have to do is, next thing we have to disable the interrupt mask. So for that you have to go to the external registers. So you will have to go to the interrupts and events. So in this you have a IMR. So external interrupt IMR. So in this we can interrupt request for the line access not mask. So we can unmask the interrupt. So we are going to send this logic one to the, which is the pin we are using. We are using is external interrupt of 3, right? So we are going to send the logic one to this external interrupt of 3. Okay. So we will send this. Interrupt. We have a IMR in this. We will want to shift the 2, 3. So we have unmasked the interrupt. Okay. Disable the mask. Okay. So what is the next thing we have to do? Next thing is we have to select the whether it is a rising edge or a falling edge. So when this interrupt should read. So we have to read at the rising edge or a falling edge. So for that go to the same interrupts. So we have a rising trigger selection register. So for rising edge selection we have to use this register. When it comes with falling edge you have to use this register. Okay. So we will select the rising edge. Okay. So when this I press the push button, when I release it, it will again go to the rise from ground to logic 1. So the interrupt occurs at the rising edge. So I will send this logic 1 to the third position. Okay. So, yes. So in this rising edge. So on shift of 3. So this will enable my, we have selected the rising edge. Okay. Okay. So what is the next thing we have to do? We have to set the priority. Okay. So wait. Before that, so now we have wait a second. So now we have created this system configuration. So what is the next thing we have to do is we have to set the priority, right? So for that we will set these priorities. So for setting the priority, we have a priority function. So we have a default ARM manufacturer's priority function, which is NVIC of set priority. Okay. So in this we have to do the interrupt. So where will be the interrupt? So go to the startup file. So in this you can see the external interrupt handler of 3. So we have to make this copy this and paste it here. Then take this handler and yeah. So this is the we have mentioned this what is the interrupt we are using. Now we are going to set this priority. So priority will be 1. So lesser value means higher priority. So next is we have to enable this interrupt, right? Because these are the peripheral interrupts. So it is not enabled by default. So we have to enable it externally. So NVIC of enable interrupt. In this we have to give this same. So now we have enabled this interrupt also. Okay. Now what is the next thing we have to do is we have to copy this interrupt handler. So this is in here when this interrupt is generated, it is going to come inside this interrupt handler only. So we are going to create a function for this. So so what is the next thing we are going to do is we are going to check with this whether this is a interrupt from the line 3 or some other interrupt. So we have to check it. We have to cross check it. So for that we have to go to the this pending register. Okay. So in this is by checking this with this third bit, we can confirm this. This is the interrupt from the external interrupt line 3. Then we are going to clear it by how can we clear this by sending the logic 1 to this the third bit. Okay. So this is the thing we are going to do. Okay. So we will create a if function if ixt. I'm going to check it with third bit because the third bit has the line 3. Okay. So then I'm going to get into the loop and I'm going to clear this. So ex on left shift of 3. So this will clear my bending register. Okay. Register. So what is the next thing I'm going to do is I'm going to create a variable which is static flag. So I'm going to do some operation here. Okay. So I'm going to give the flag as 1. So then I'm going to exit this loop. Okay. So we will declare these all things in the will declare all these things. So now we have declared it. So what is the next step we are going to do is we are going to create a int main function. Okay. So int main of void. Okay. So what is the first thing I have to do? So I have to call this two functions. Okay. So what are the functions? First I will call the GPI. Next is interrupt. So what is this? Interrupt. Okay. So what is the next thing we are going to do is we are going to we have declared these things. Okay. So we are going to create another variable which is a static of count equal to 0. Okay. So I'm going to create a while. So now I'm going to check if the flag is 1. So if the flag is equal to 1, then it will get into this loop and increment the count. And I will make the flag as 0. Okay. So then it will like this. So now we will compile this. Okay. So now we will compile this. Okay. So so we have one error. Okay. So we have to mention this in this format. Okay. So for mentioning it, we have to give in this format. Okay, we have consulted this control register 1. So next is we have to give here. So now we will compile this and we will upload this code. Okay. So before that, wait. So I will compile. So before compiling, we have to select this STM debugger because I am using this STM debugger. Okay. The ST link. So go to the settings. Okay. So now we have need to upload the code. So we will upload this code. Then we will see the output. Okay. So when I wait, I will. So what is the process going to be is when I give this we have set this pin as external line pin 3 as an wait, external pin 3 as an in input mode in a PD of 3. So we are configured pin as PD3. So in this we are set to the pull your pin at we are set to the pin at the pull up stage. Okay, pull up stage. So that means it is in the logic of 3.3 volt, which is logic 1. Okay. So what is going to happen is when I give this connected this pin with the ground means it is going to pull down those logic 1 to logic 0. Then after I'm when this I remove this disconnected this ground means then it is going to again it is going to rise it, going to get back to the logic of 1. So there it will generate a rising edge. When the rising edge is generated, the interrupt will get into this loop and check whether this interrupt is from the external line 3, external interrupt line 3. Then it will clear those bending registers and it will make the flag as an 1. Then when this flag is 1, then the count will be added when the count is initialized in the 0. So the count will be added and the flag will again set to the 0. So this is the process what is going to done. Okay. So now I will run this. So now I will connect this ground. Okay. I will connect the PA pin of 3, right? So 3 with the ground. So you can see now our count is increased because it is getting into our interrupt and the flag is getting one settled and the count is getting increased. Okay. Again I will give the push button. Okay. So I am pushing the button, but the count will not increase at the when I push the button. When I because I am giving at the rising edge, right? I am calculating at the rising edge. So when I release the button only, it is going to rise the logic 0 to 1. So then the interrupt will occur at the rising edge. So you can see that the count is increasing. So in this way, we can use this interrupts. So for example, and we can say we have already developed the code for the UART and ADC, right? So ADC is continuously giving a value and UART is continuously printing. Now I have created an interrupt that ADC channel ADC interrupt. When the channel is increased, it is going to create me an interrupt. So what is this interrupt is going to do is it is going to tune off the engine. Okay, we will consider take that scenario. So what is the scenarios? The ADC is reading the temperature value using the temperature sensor which is connected to the engine. So when this temperature is, exceeds value which is predefined, so we will consider it as a 60 degrees Celsius. Okay. When this engine rises the 60 degrees Celsius, then ADC will give the interrupt. All the main program will be altered. The printing of the value also will be altered, and it will tune off the engine, cuts the main power to the engine. So it will generate the interrupt. Inside the interrupt handler, there will be a code that to cut off the engine power. So by that, when this interrupt is generated, it will cut off the engine power, and the engine will be tuned off to cool down. So then only it will show the UART reading. So it will display the reading in the serial monitor that the engine is tuned off, the temperature is raised above 60 degrees Celsius, so it is tuned off. So this is how the interrupts are used in the industrial way. Okay. So okay. So today's class is over, guys. Tomorrow we will meet in tomorrow's session. Okay. So thank you.